In this video, we're going to be taking a look at 4 different example problems that deal with absolute pressure and gauge pressure. The first question right over here says a tire has an absolute pressure of 0.75 atms. What is its gauge pressure? So for absolute pressure, it is the sum of our gauge pressure plus the atmospheric pressure. So just the regular amount of pressure provided from the air molecules of the atmosphere itself, which we know is 1.0 atmospheres. And we're looking for the gauge pressure, and we have the absolute pressure of 0.75 atms. So we have an unknown gauge pressure that we're looking for. So all we have to do is a very simple algebraic step, which is just subtracting 1 from both sides. And then we have a gauge pressure that's negative 0.25 atmospheres. And the number comes out negative to show that the pressure caused from the fluid, which would be probably the air inside of the tire, is less than the regular 1.0 atmospheres of the regular environment itself. Let's go ahead and take a look at the second problem. We have a sealed container that has a gauge pressure of 400 kilopascals, so we're working with a different unit. And what is its absolute pressure? So again, the absolute pressure is taking a look at the sum of the gauge pressure caused by the fluid, which is some kind of gas or liquid. And then we also have the pressure of the atmosphere itself. So for this one, we have everything on the right side of our equation to find our absolute pressure. And we have the gauge pressure of 400. And then for the atmospheric pressure, since we're not in ATM, we're on kilopascals. That is 101.3 kilopascals. Now that we've changed units, and then all we have to do is sum those up. So that's pretty simple. 400 plus 101.3 is 501.3 kilopascals. So mathematically, we're not dealing with anything too complicated. You just have to know that we have atmospheric pressures in different units. Ones like atmospheres or kilopascals would be fairly common. And then the gauge pressure, like I said earlier, is the pressure that is from the fluid, which is either some kind of gas or liquid, typically in some kind of sealed container in a lot of these cases. All right, so let's go ahead and take a look at 2 slightly more difficult problems. Now for our second 2 problems, it says a diver is 60 meters under the surface of the water. So we have some water here, and we're going 60 meters below. That's where our diver is. And then we also have some air molecules out here causing some of that atmospheric pressure. So we have 2 different pressures that we're combining. This one we would call the atmospheric pressure, and this one we would call the gauge pressure from our liquid, which is the water. And we're going to introduce a new formula here as well. And we want the absolute pressure, so that's kind of our total of everything that is being pushed down towards the person. And we have atmospheric pressure plus this gauge pressure equal to the absolute or total pressure. So when we're working with the gauge pressure, especially when we're working with a fluid or a liquid like this, we're going to want to use the formula rho GH. And if we're using rho GH for water, it's going to be 1,000 kilogram meters cubed for the density, 9.8. Our constant G value, acceleration due to gravity, and then we have the height of 60 meters. Now, when we take the product of these 3, our number is going to come out to 588 8,000 pascals. Now before, for our standard number that we use for the atmospheric pressure, when we're in pascals, we had 101.3 kilopascals. So what we want to do is an additional step here and divide this by 1,000 and convert it to 588 kilopascals. So they're in the same unit. Now we have a pretty simple problem. All we need to do is take the 101.3 kilopascals plus the 588 kilopascals, and that's going to give us our absolute pressure. Once we sum those up, we get 689.3 kilopascals. So a couple new things to be introduced if we're taking a look at the pressure from the water. Then we're going to want to use the formula rho GH. And then also we're going to want to do a bit of unit converting so that our units are all in kilopascals. And then we have our final answer of 689.3. So let's go ahead and get into our last question. We have a large container that has 0.5 meters of oil above a 1 meter layer of water. So we got 1 meter of water, which we'll call H2O. And we've got some oil up here, 0.5 meters above. And we're asked, what is the absolute pressure at the bottom of the container if the oil has a density of 800 kilograms per meter cubed? And of course, we have our regular atmospheric pressure that's going to be of our container, above our container over here. So what we're going to want to do is sum up those three pressures. So the atmospheric pressure, pressure from the oil, and the pressure from the water. And once we sum those three up, that is going to be our total absolute pressure at the bottom of our container. So what we want to do is go ahead and take that 101.3 kilopascals, and then for oil, we're going to want to use the rho GH formula that we used earlier, and we're going to want to use that for both of these fluids over here. So the rho for the oil was given to us in the problem, 800 times 9.8, and then we have 0.5 meters of that oil. And then for water, we still have 1,000 kilograms per meter cubed as usual, 9.8 Sg as usual as well, and then 1 meter of that water. When we slide to our next step, this comes out to 3,920, and this one comes out to 9,800. So what I'm going to do is divide both of these by 1,000, which is basically scooting the decimal 3 to the left. So then I'm going to sum up these numbers as 101.3 plus 3.92 plus 9.8, and then everything is going to be in kilopascals. And then we get 115.02 kilopascals as our absolute pressure. So for this one, it wasn't too much different than the diver problem that we just previously solved for. We just have two different liquids that we're dealing with here. So we just had to have two different rho GH calculations. Same thing, do a little bit of converting, sum them up, and then we got our final absolute pressure. So I hope that was helpful and help you understand absolute and gauge pressure problems and see some various examples. Thank you for watching and listening.